This is the brief on foundational chemistry concepts, atomic structure, mixtures, and the periodic table. So today we're going to break down some key chemistry basics. You know, how we figured out what atoms actually look like, how we separate stuff like salt from water, and why the periodic table is kind of like a cheat sheet for elements. All right, we've got three main things to cover. Let's dive in. First off, our idea of the atom, that really changed over time. You know, Rutherford figured out there's this tiny, dense nucleus in the middle, then Niels Bohr came along and suggested electrons kind of orbit around it at set distances. But here's the thing, atoms of the same element aren't always identical. They can have different numbers of neutrons. Those are called isotopes. That's why the relative atomic mass you see on the table, the R, isn't just one atom's weight. It's actually a weighted average, kind of reflecting the mix of isotopes found in nature. Make sense, right? Second, it's really important to get the difference between pure stuff and mixtures. Think about steel or even just air. Those are mixtures. And the cool part is, you can physically separate them. How? Well, you could use distillation, which uses different boiling points, like getting pure water from salty water, or chromatography, that separates things like ink colors based on how they travel. And you ever wonder why alloys, like steel, are tougher than pure metals? It's because mixing different sized atoms messes up the neat layers inside, making it way harder for them to slide around. Finally, let's talk patterns in the periodic table. Group 7 elements, the halogens, super reactive, always trying to grab an extra electron. But as you go down the group, they get less reactive. Why? Because that outer electron shell is just further away from the nucleus, making it harder to pull in that electron. Now, compare that to the transition metals in the middle. They're way harder, stronger, denser than group 1 metals. And here's a key thing. They can form ions with different charges, like iron doing both Fe2+ and Fe3+. Pretty flexible. So, getting a handle on these basics, how atoms are built, how mixtures work, and those table trends, that's really the language you need to understand pretty much all of chemistry.